Okay, now let's talk about main effects and interactions. The reason that you do factorial design is because you suspect that the effects of one independent variable might have an influence on the effects of another independent variable. You may have heard that term, the whole is greater than the sum of its parts. That's kind of another way of saying an interaction, that the combination is somehow greater than just the additive value. So the main differences among the levels of one factor, that's your main effect. So if we were just looking at caffeine, or if we were just looking at alcohol, that would be our main effect. What's the main effect of caffeine? It speeds you up. What's the main effect of alcohol? It slows you down. So when we look at the mean differences along one factor, so the mean difference of alcohol versus no alcohol, when you collapse across all the caffeine conditions, that gives you a main effect of alcohol. We see that alcohol slows you down regardless. And if we were to collapse across the alcohol conditions, we'd see that the more caffeine you get, the speedier you are at finishing the task. So the caffeine makes you faster. There's a main effect of caffeine. The alcohol makes you slower, regardless of the level of caffeine. So there's a main effect of alcohol. Now, an interaction is what happens when the results of one independent variable has an influence on the other independent variable. In other words, it's not what you would predict just from the overall main effects. So an interaction, in other words, is what happens when the effects of one factor depend on different levels of a second factor. That's what we see here in this graph. We see that the effect of alcohol depends on caffeine, or you could put it the other way. The effect of caffeine depends on alcohol. In this case, what it's seen is the magnitude of the difference between our drinkers and our non-drinkers lessens the more caffeine they have in their system. So it's not just that caffeine makes you faster, even though that's true, and it's not just that alcohol makes you slower, even though that's true. There's another thing going on here, and that's the degree of difference between our drinkers and our non-drinkers shrinks the more caffeine you get. Notice that means these lines are non-parallel. Non-parallel lines are often a good visual indicator that you're dealing with an interaction. Now, there are also ways to statistically test for it as well, and we'll get into that later. That's what we'll cover in Data Project 4. But for right now, just know that the more non-parallel the lines are, the more likely it is that we're seeing an interaction. So when the results of two factors study are graphed, non-parallel lines suggest an interaction. Here's what it might have looked like if we had a main effect of caffeine and a main effect of alcohol, but no interaction between the two. So here we've got our caffeines, 0 milligrams, 200 and 400. Our reaction time, we have alcohol in purple there, no alcohol in dark blue. This is what it would have looked like if the two had a main effect but not an interaction. What does that mean? Well, we see there's a main effect of caffeine both for our non-drinkers and our drinkers. The reaction time goes down the more caffeine they get. And for each level of caffeine, we see that alcohol, the alcohol group, is slower than the no alcohol group. And notice that we don't see a degree of difference change, right? It's the same level of difference throughout. They both might be sloping down, but the gap between our figures stays the same. So that's what it would have looked like if alcohol and caffeine had not interacted. Instead, what we saw was this, right? We saw a slope, non-parallel slopes. The magnitude of difference between our alcohol and our no alcohol group depends on how much caffeine is in your system. So that's an interaction, but this is just a main effect of alcohol and a main effect of caffeine, no interaction. Here is what it would look like if there were an interaction but no main effect. So if your lines actually cross, if they make an X, that's a signal that there's no main effect but there's an interaction. See, if this were true, and of course, clearly this data is made up because it doesn't make any sense, but if this were true, then with no caffeine, our no alcohol group would be faster. With a little bit of caffeine, it doesn't matter whether you're drinking or not, it's the same number. And if you get a lot of caffeine, our alcohol group is actually outperforming you. It's doing faster. Okay, so obviously that doesn't make a whole lot of sense, right? Why would you ever do faster if you had a lot of alcohol in your system? But this shows us what it would look like if there was an interaction without a main effect. In other words, there'd be no effect of caffeine on its own, no reliable effect of alcohol on its own. It would all depend on the combination of the two. So if you have no main effect but an interaction, that means that the only thing that's really important is how the two combine. Okay, so that's the end of this one. When we come back, we'll talk about the different kinds of factorial design.